In this video, I hope to show you how we can advance model-driven decision-making through AI assistance. I'm Lonnie Chrisman, the Chief Technology Officer at both Lumina Decision Systems and for today at OmniCognition Robotics. I focus specifically on tools to promote model-driven decision-making. This is the approach of building a computational model for your decision situation and using the insights you derive from that model to help you make better and more principled decisions. This paradigm is a generalization of data-driven decision-making and is a core foundation for the decision sciences. It's a very highly regarded and effective approach for large and high-stakes decisions, especially those involving strategic planning, situations with little or no historical precedent, and decisions involving multiple stakeholders, where it can be quite effective in breaking through advocacy positions. However, the main obstacle to using model-driven decision-making is that you have to build a model, and that involves effort and expertise. This is where new AI-based tools may help, particularly if they can help to lower the effort and expertise required for model-driven decision-making. Indeed, I think AI and decision modeling are highly synergistic. Not only can AI help us with decision modeling, but I see decision models as a key touch point between the decision maker and AI, in which decision models will help us gain an improved and faster understanding of AI rationales and insights, as well as giving us a way to avoid negative consequences from misalignment, biases, and hallucinations. To bring these ideas to life, I've created Assista, the Analytica AI assistant. Rather than just talking about these synergies and abstract ideas, I want to show you. In this demo, you'll see Assista in action during a collaborative model building session. Because, as I like to say, a picture is worth 1,000 words, but a demo is worth 1,000 PowerPoint slides. Today, OmniCognition's first humanoid robot that you see here is ready for production. Originally, we were planning on locating our factory for assembling these in the United States, but recent threats by the US to impose tariffs have forced us to reconsider that decision. You see, nearly all our components are sourced from countries that are subject to these tariffs, and furthermore, most of our prospective customers are outside the US, where reciprocal tariffs would hurt our competitiveness. So now we are deciding between locating our factory in Canada versus going with our previously selected location in the US. So now I'm going to show you a session of me working with Assista to build a decision model for this. Okay, I am building the model in Analytica, which has Assista now included. I start out by entering a title and a description. Now this description not only helps people understand the model, but it's super important for Assista. Assista sees the description and it's fundamental for helping it understand what we're working on. So I always try to write a nice detailed description. Here I'm basically writing what I've already mentioned. Now I open the Assista window. And I'm going to start out by asking the first question. Please help me design an influence diagram for this problem. We'll see what it does. Okay, so it says to start, we'll need to get a clear understanding of the objectives and decision variables. Based on the provided context, your primary objective seems to be maximizing profit measured in US dollars per year. Does that sound correct? Would you like to include any other objectives? For decision variables, it seems that choosing a factory location is a key decision, with options being either US or Canada. Are there additional decisions that might need to be considered? So I'll say, yeah, profit in US dollars per year is the objective, and factory location, as you suggest, is a decision. Another decision under our control is unit price, i.e. what to charge for each robot we make. Please go ahead and add these to the model. Now on the diagram, watch as Assista creates 3 new variables, an objective and 2 decisions. Now I like to rearrange these and put the objective over on the bottom right and the decisions on the left. And then we'll kind of connect those as we build the model. So it said, I did this, and now let's consider any chance variables that might significantly influence your decisions. For example, potential chance variables could include tariffs imposed, tariff rates if imposed, and two others. So would you like me to add these variables? Let's do only the first two, tariffs imposed and tariff rate if imposed. Assume for now that any reciprocal tariffs are the same, so we don't need separate variables for that. I'd also like an uncertain fixed cost variable that depends on factory location, because operating in Canada is going to be a bit more expensive than operating in the US. Finally, in addition to those, add a variable tariff rate that's going to compute our actual tariff based on the other variables we've mentioned. Okay, let's again watch the diagram. And I think Assista is going to add some more variables. There they are, with some arrows connecting them. So once again, I like to rearrange these to make it look nice for me. So let's just bring these over here, kind of organize it. Okay, good. Next, okay, it says the next steps would be to identify intermediate variables that connect these components to your objective, profit, by capturing factors like production costs, sales volume, and revenue. Let me know if you need help setting those up. Okay, which intermediate variables would you suggest? And make sure you keep it as simple as possible. Okay, we see it. Oh, look at that. It suggested 6 variables there, and it asked if I would like to add these to the model. So I'm going to go ahead and say, yes, I would. Please add those to the model. Okay, there they are. Boom, boom, boom. And now some arrows appear. Okay, let me rearrange them again to kind of make it look how I like to look at it, and also kind of untangle the arrows. So now, let's see. As I get those in there, let's take a look at customer price and numbers sold. So numbers sold depends on customer price, right? As the price goes up for the customer, we're going to sell fewer, and tariffs are going to drive the price up. So how could we go ahead? I mean, how could we go about modeling the numbers sold so we get that kind of relationship? Well, this is something we might ask Assista about. Okay, so I'm going to type, how should I model the number sold so it decreases with increased customer price? Okay, and I see it has suggested a constant elasticity of demand model, which adds a few more variables to the model as well. I think that's a pretty good suggestion, actually. So let's say yes, go ahead and add these, but let's make the base market size and the price elasticity both uncertain. So we'll make them chance variables. Okay, it added a couple more variables there and some arrows. And it printed out some information about what it just did. So let me put the new variables in front of numbers sold. So, okay, and there we go. All right, so now we have a complete influence diagram, but none of the variables are defined. That's why they're all cross-hatched. So I'm going to go ahead and fill in a few. So first, the components, we have about $70,000 worth of components that go into each robot. We're thinking of charging about $120,000 for each robot. We'll make that the reference price as well for the elasticity. And then for, let's say, tariffs and factory location, so it already filled in the domain of US and Canada. Okay, so, and it also filled in the description and the title for us. So what I'm going to do is I'm just going to make this a choice control. That makes it really easy for me to select whether I want to compute US or Canada. And we'll just start by computing both. And then let's see, can I fill in something else? Let's go ahead and fill in tariff imposed. That's an uncertain variable, so I'm going to put a probability in there. Let's say it's a 0.7 probability that the US imposes tariffs. And for the tariff rate, if imposed, let's have Assista actually select the distribution, but I'll tell it what I think. So I'm going to say set this to be a distribution with a 10-50-90 of 15%, 25%, and 35%. Okay, so we'll watch it there. It filled in the distribution using the uncertain low, medium, high distribution function, which specifies those parameters. Let's look at the actual distribution to see what that looks like. Okay, so that's the distribution it selected, okay, which has those quantiles that I asked for. And let's see, what else can I fill in? Price elasticity. Man, this is a completely new market. I mean, there's never been a mobile humanoid robotic market. So I have no idea what the price elasticity should be. So why don't we ask Assista? It has a broad knowledge of everything ever written by humankind. So I'll just say, can you make an estimate for the price elasticity of our robot product for me, given that it's a new market and and so I'll say reason it through and then set this to a distribution when you have an estimate. Okay, so it's come up with an estimate. It's first over on the chat, it's reasoning it through. It says, thinks about product type, market familiarity, comparison to other similar products, and market dynamics. And it came up with a low, medium, high of -4, -2, -1. The negative, of course, meaning that a higher price leads to a smaller number sold. Okay, I'll just go ahead and set fixed costs. We have a different fixed cost in the US and Canada. In the US, it's like around $50 million a year to operate the factory, but in Canada, it would be like $120 million a year, okay, with some uncertainty around it. And just looking at what that distribution looks like, those two distributions look like, you can see there the Canada distribution is shifted right a little bit. And what else? We have the base market size. I'll just fill that in with where I think the base market size is. And now I think we have all the inputs defined. All that remains is a bunch of computed variables. So I'm just going to say, please complete filling in the definitions for all remaining undefined variables. So we're going to leave it to understand what these mean and figure out how to compute them. Okay, so it's writing out some formulas. And it looked like it's finished. Everything's not hatched. I'm just going to go through and just do a sanity check on these. Make sure they look right. Okay, yeah, good. And I think they look okay. So let's evaluate profit. Now we can compute it. Okay, so let's look at the density first. We can see that the blue curve is operating in Canada. That's our profit. And a little bit to the right is the US. As a cumulative distribution, we can see that it's kind of uniformly to the right. Canada's to the right. Okay, which means it's a little bit higher in profit than the US. And there's the mean. So now finally, let's ask Assista to interpret this. So based on this model's calculations, would you recommend that we relocate our factory to Canada? And I think this one is going to be worth reading in detail because it's often very insightful. So to assess whether relocating the factory to Canada would be beneficial, we need to consider the profit calculations for both locations. We can see the bigger profit there for the Canada. The calculated profit is significantly higher in Canada than in the US. This suggests that, based on current assumptions and model parameters, relocating the factory to Canada may be more profitable. Factors contributing to this recommendation could include differences in tariffs, costs, and market dynamics that favor the Canadian location. It's important to evaluate whether these estimates reflect the actual business context and confirm that no critical factors have been overlooked by the model. Keep in mind that while these results are favorable for moving to Canada, the decision should also consider other strategic factors such as long-term market trends, infrastructure and logistics, political and economic stability, and other non-monetary considerations that may affect the long-term success of the business. So I think that's pretty neat how it understands that a model is only an approximation of reality. You shouldn't blindly trust the whole model, and there's other factors that haven't been modeled. And in fact, it even has an idea of what those unmodeled factors are. I hope this demo of Assista with the fictional example of OmniCognition Robotics has given you inspiration and ideas about the potential of AI assistance both now and in the future. To conclude, AI assistance and model-driven decision-making are transformative partners, with AI promising to make model building faster, easier, better, and possible for more people, while at the same time, the decision model will serve as a critical touch point for the deployment of AI. Even when a future AI system reaches a point where it can perform the entire research and analysis of a decision situation and recommend the best choice of action, for important and high stakes decisions, you should still demand to understand the rationale to ensure that it actually aligned with your goals, not to mention the influences of its biases or hallucinations. This makes the model driven paradigm an important component for future AI. Today, I hope Assista is sometimes genuinely useful, but it is the worst that it will ever be. I expect there to be a sharp transition as it gets a little more capable, and we'll see its usefulness skyrocket, rapidly transitioning from being sometimes useful to being indispensable. As AI assistants lower the expertise required, this technology will extend the reach of model driven decision making, enabling more people to make better and more principled decisions. And finally, as you've seen from the demo, AI assistance is all about the human and AI collaboration. This is very much a case where each complements the other.